Today, we're going to talk about functions in Python. So far, we've been writing programs where all of the code runs line by line from the top. But as our programs grow, that approach becomes messy and harder to manage. Functions give us a way to break down a problem into smaller, reusable pieces. They let us group related code together. So instead of writing the same steps over and over, we can just call the function whenever we need it. By the end of this lecture, you'll see how functions help make code cleaner, more efficient, and much easier to read. Let's start by talking about what functions are. A function is a self-contained block of code that performs a specific task. You can think of it as a reusable tool. Once you define it, you can use it again and again without rewriting the same code. Functions usually take in data, do some processing with it, and then return a result. This structure makes programs easier to organize and maintain. Another big advantage of functions is reusability. Once a function is written, it can be called as many times as needed, even from different parts of your program. Finally, packaging code as a function avoids duplication. Instead of copying the same chunk of code everywhere, you just call the function. This not only saves time, but also makes your code cleaner and easier to debug. Here's a simple way to think about functions. Imagine a machine. On one side, you put something in. The machine then follows a set of rules. In this example, the rule is multiply by 2 and then add 3. After processing, the machine gives you an output on the other side. That's exactly how a function works. You give it input data, it performs a series of steps, and it returns an output. For example, if I put in the number 4, the machine first multiplies by 2 to get 8, then adds 3, giving us 11 as the output. This idea of input, process, and output is the foundation of how functions operate in programming. In Python, there are really two kinds of functions. The first are the built-in functions that come with the language, like print for displaying output and type for checking the type of a variable. We've actually been using these built-in functions since the very beginning of the course. The second kind are user-defined functions, which are the ones we create ourselves. These let us package our own code into reusable blocks. So instead of rewriting the same logic again and again, we can just call the function whenever we need it. Up until now, we've relied on Python's built-in functions, but now it's time to start writing our own. To define a function, we use the keyword def, followed by the function's name, then parentheses for any input parameters, and finally a colon. Inside the indented block, we write the instructions we want the function to carry out. The basic structure is shown on the slide. So from this point on, we're not just going to use the tools Python gives us. We'll also learn how to build our own tools. Here's our very first example of a user-defined function. We start with the def keyword, followed by the name of the function. Here it's called my underscore function. Notice the parentheses and the colon. Inside the indented block, we have the code that we want this function to run. In this case, the function will simply print the message, hello from a function. Right now, we've only defined the function. That means we've told Python what this function should do, but it hasn't run yet. To actually make it run, we'll need to call the function later in our program by writing my underscore function open parenthesis close parenthesis. So think of defining a function as giving Python the instructions and calling a function as telling Python, okay, now go and do it. Once we define a function, we still have to tell Python when to actually run it. That's called calling the function. To call a function, we write the function's name, followed by parentheses. If the function expects any input, we put those values inside the parentheses. At the top, for example, we define the function, just like before. But now notice what happens when we call it. On lines 4, 5, and 6, the function is called 3 separate times. My function, and my function. When we run this program, Python executes the function each time it's called. That's why in the terminal at the bottom, you see the message hello from a function printed 3 times. The key idea here is that once a function is defined, you can reuse it as many times as you need without rewriting the code. Every time you call it, Python jumps into that block, runs the instructions, and then comes back out with the result. Whenever we write a function, it's a good practice to include a short description of what the function does. That description is called a docstring. A docstring is written as the very first line inside the function, enclosed in triple quotes. It tells anyone reading the code, yourself included, what the purpose of the function is. In this example, we've created a function called printSum2 that takes in 2 numbers and prints their sum. Right under the function definition, you see a docstring that says, this function prints the result of adding 2 numbers. Later, if we want to see that description, we can access it using the special attribute __doc__. When we call print function on line 6, Python prints out the docstring we wrote. This is really helpful for documenting your code, because as your programs get bigger, docstrings make it clear what each function is supposed to do. When a function finishes running, it always gives control back to the part of the program that called it. But sometimes we want the function to not only finish, but also hand back a value that we can use later. To do that, we use the return statement. The return statement allows a function to send a result back to the caller. For example, imagine we write a function that adds 2 numbers together. Instead of just printing the sum, we can return it. That way, the caller can store the result in a variable, use it in a calculation, or even pass it to another function. This is a big difference from just using print. Printing shows the result on the screen, but returning actually gives the result back to the program so it can be reused. Here's an example of a function that uses the return statement. This function is called add2. It takes in 2 inputs, adds them together, and then returns the result. Notice how the variable sum stores the addition, and then the line returns sum hands that value back to the caller. On lines 6 and 7, we call the function twice, first with 11 and 22, and then with 10 and 10. But here's the important part. Since the function returns the result, we can wrap it inside a print statement. That way, the output is displayed in the terminal. When we run this code, Python prints 33 for the first call and 20 for the second. The key idea is that a return value can be reused anywhere in the program. Instead of just printing the result inside the function, returning allows us to save it, use it in another calculation, or combine it with other logic. So far, we've seen how a function can return a specific value using the return statement. But there are also cases where a function doesn't return anything useful. One way this happens is if we write a return statement without giving it an expression. That immediately ends the function and implicitly returns the special value none. In Python, none represents the absence of a value. You can think of it as Python's way of saying, there's nothing here. Also, none evaluates to false in conditions. Another way this can happen is when a function doesn't include a return statement at all. In that case, once the function finishes its last line of code, it automatically returns none by default. So remember, every function in Python always returns something. If you don't explicitly tell it what to return, it will return none. Let's look at 2 quick examples that show how functions behave when there's no return value. The first function, do something, simply prints the letter A. There's no return statement here, so once it finishes printing, Python automatically returns none by default. The second function, do something else, prints the letter B and then has a return statement. But notice there's nothing after it. That means the function also returns none. At the bottom, we call both functions. The first call prints B and the second call prints A. In both cases, even though the functions return none, we don't really see it because nothing is being done with the return value. This is an important point. Every function in Python always returns something. If you don't give it a value to return, it will return none by default. In Python, the keyword none is used to represent a null value or no value at all. It's Python's way of saying there's nothing here. In this example, we assign my variable equals none. When we print the variable, Python literally prints out the word none. If we then check its type using type open parenthesis, my underscore variable close parenthesis, Python tells us it belongs to a special class called none type. So none isn't the same thing as zero, or an empty string, or false. It's its own special type that represents the absence of a value. This is why when a function doesn't return anything, Python automatically gives us none as the return value. It means there's no actual value to pass back. Now here's something important to know. If you use none inside an if condition, Python will treat it as false. So while none is different from zero, an empty string, or false, it still evaluates to false when used in conditions. In Python, every function definition must have at least one line of code inside it. If you leave a function completely empty, Python will give you an error. But sometimes when you're writing code, you might want to define the structure of your functions first and come back later to fill in the details. In that case, you can use the pass statement as a placeholder. For example, in this code, important underscore function and another underscore important underscore function both use pass. This tells Python, do nothing here for now, but don't raise an error. On the other hand, the function VeryEasyFunction has an actual statement inside. It prints out the word hello. So the pass statement is just a way of saying, I'm leaving this function blank for now, but it's still valid Python code. It's especially useful when planning out your program structure before you've written all the details. Sometimes when we define a function, we want to give one or more of the parameters a default value. That way, if the user doesn't provide an argument for that parameter, Python will automatically use the default. In this example, the function rectangle area has two parameters, length and width. The default value for length is set to 2, and the default for width is set to 3. Inside the function, it simply returns the area by multiplying length by width. Now look at the different ways this function is called. On line 5, we call it with two arguments, rectangle area 5, 5. That means length equals 5, and width equals 5, so the result is 25. On line 6, we call it with no arguments at all, rectangle area. In this case, Python uses the default values, length equals 2 and width equals 3, so the result is 6. On line 7, we call it with just one argument, rectangle area 5. Here the length becomes 5, but since width isn't provided, Python falls back on the default width equals 3. That gives us 15. The key idea is that default parameter values make our functions more flexible because they can work with different numbers of arguments depending on what we need. When we use default parameter values in Python, there's an important rule to follow. Any parameters with defaults must come after the ones that don't have defaults. In this example, the function rectangle area takes two parameters, length and width. Only width has a default value of 3. Notice that length, which doesn't have a default, is listed first. If we tried to put the default parameter before a non-default one, Python would give us an error. Here's what happens if we don't follow the rule about default parameters. In this example, the function rectangle area has length equals 2 as a default parameter, but then width has no default value and comes after it. Python does not allow this. Remember, all parameters without defaults must come first, and any parameters with defaults must come after them. If you try to put a default parameter before a non-default one, Python will raise a syntax error. So in this case, Python is flagging an error right at the function definition. The program won't even run until the parameter order is fixed. This is why the correct version of this function puts length first with no default and width equals 3 after it. Following this order ensures Python can match up arguments correctly when you call the function. When we call functions in Python, We normally pass arguments in the exact order the parameters were defined, but Python also gives us a more flexible option. We can use keyword arguments. A keyword argument is when we explicitly name the parameter while calling the function. This means the order no longer matters because Python matches values by name, not by position. Here's an example of keyword arguments in action. Our function rectangle area has default values for length and width. On line 5, we call it with rectangle area width equals 10. Since we didn't specify the length, it uses the default value of 2. That gives us 2 times 10, which is 20. On line 6, we call it again, but this time with both keyword arguments. Rectangle area width equals 10, length equals 1. Notice that the order is flipped. Width comes first and length comes second, but it still works perfectly because Python matches values by their parameter names. This one gives us 1 times 10, which is 10. So keyword arguments let us call functions in a way that's both flexible and more readable, especially when there are many parameters. Now, to wrap up today's lecture, we covered the essentials of functions in Python. We looked at how to define functions, how to call them, how to use docstrings for documentation, the difference between printing and returning values, the role of none, and even advanced features like default parameter values and keyword arguments. The big takeaway is this: functions let us organize code into reusable, manageable pieces. They're one of the most important tools in programming, and from this point forward, almost every program we write will involve functions. Thank you. This presentation was prepared by June Lee with the assistance of AI technology.